Assalamu alaikum children, how are you all? Hope you all are very fine, fit and healthy. Children, in last class you have learnt about conversion of energy like mechanical energy and electrical energy, chemical energy and solar energy converted into this heat energy. So other forms of energy are converting into heat energy. Not only other forms are converting into heat energy, but also heat energy is converted or transformed to other forms of energy. Like you may have seen in thermal power station, heat energy is converted into electrical energy, and in a steam engine, heat energy is converted into mechanical energy. So now, children, we are going to learn about heat and temperature in this session. So let us see. If you stand close to fire, you will feel warm. When a warm object is placed close to a cooler object, heat energy moves from the warmer object to the cooler one until both objects attain the same temperature. Often, we think that heat and temperature are the same things. This is wrong. Temperature is a measure of the heat energy in your body and which indicates the ability of your body to give heat to another body or absorb heat from another body. We use an instrument called as thermometer to measure temperature. Now you are seeing here and different types of thermometers. So children, have you observed any thermometer in your daily life? Have you seen the thermometer used by doctors in hospitals? What does it contain? How does it help us to measure the temperature? Let us observe a thermometer. Hold the thermometer and observe it carefully. What is it made up of? What do you find inside the thermometer? What do you find at both ends of the tube? How do they differ from each other? At one end of the tube, you observe a bulb. It is filled with mercury. What do you observe at the other end of the tube? Let us see. The other end of the tube is sealed after removing air from it. Do you find any markings on this tube? We find a scale which is marked to express temperature in degrees Celsius. We read the temperature with the help of these markings. Read the markings on the tube. Where does it start? Where does it end? This arrangement of the marks is called scale of temperature. All thermometers are based on the fact that matter expands on heating. To understand the working of a thermometer, we need to know how matter expands on heating. So for this, let us do a simple activity, that is expansion of a liquid due to heat. To do this activity, take a flat bottom flask and fill it with colored water. Fix a cork having a capillary tube and the mouth of a flask such that level of water is as shown in figure 9 you are seeing here. Place the flask in a metal trough. Pour boiling hot water into the trough and carefully observe the level of colored water. What do you observe? If you take the flask out of the trough, keep it outside for some time. What do you observe? In the above activity, we see that water expands on heating and contracts on cooling. So does mercury and is used as liquid for indicating temperature in thermometers. Apart from mercury, we also use alcohol as thermometer liquid. Think, why do we use mercury or this alcohol as thermometer liquids? So, in order to know this, let us see some properties of mercury and alcohol. Properties of mercury. Its expansion is uniform. For equal amounts of heat, it expands by equal lengths. It is opaque and shining. It does not stick to the sides of the glass tube. It is a good conductor of heat. It is easily available in pure state. Let us see the properties of alcohol also. It can record very low temperatures. Its expansion per degree Celsius rise in temperature is very large. It can be colored brightly and hence is easily visible. Now, now let us see how to use a thermometer. To find the temperature of an object, the bulb of the thermometer needs to be in close contact with the object. Watch the shiny line of mercury in the tube, the highest point on the scale at which the rise of mercury stops shows the temperature of the object. For example, to find the temperature of your palm, place the bulb of a thermometer in contact with the palm for 2 minutes and see the mercury rise. When mercury stops rising and its level becomes steady, note the position of its upper end. This is the temperature of your palm. How much is it? If markings on thermometers are wiped out, how do we create new markings? Let's see. Take some ice in a beaker. Immerse a thermometer in ice for 2 minutes. Mark the mercury level. Now let the ice melt. Can you observe any change in mercury level? So the level of mercury remains same while ice melts. This means the temperature is constant. This constant temperature at which ice melts is called melting point of ice, and we mark it as 0 degrees Celsius. Take some water in a beaker, immerse the thermometer in it, and start heating the water. It will start boiling while getting converted into steam. Mercury level starts rising and reaches a point beyond which it doesn't rise. Mark the level of mercury at this point. Observe the constant level at which mercury stays while water is boiling. This constant temperature is called boiling point of water. We mark the level of mercury at this point as 100 degrees Celsius. Thus, temperature at which ice melts or water boils is constant. These values are fixed as 0 degrees Celsius and 100 degrees Celsius respectively. Like water, all substances in pure form melt and boil at certain fixed temperatures. To create a scale, we need two fixed points. Let us choose a melting point 0 degrees Celsius and boiling point 100 degrees Celsius as two fixed points for the scale of thermometer. Now divide the distance between these 2 points on the thermometer into 100 equal parts. Think about how we can achieve this. Each of the 100 equal parts represents 1 degree Celsius. We further divide 1 degree Celsius into 10 small divisions. It can be read as 1 by 10, that is equal to 0.1 degrees Celsius. Now you can precisely determine which water is cooler and which is hotter than the other in the 3 beaker experiment that you have seen in session 1. If the temperature of the beaker in which we immersed both the hands is 41 degrees Celsius, what can be said about the temperature of water in other beakers? Let us see. The beaker containing cooler water will record temperature less than 41 degrees Celsius. The beaker containing hotter water will record temperature more than 41 degrees Celsius. Now, let us see. We are using units of temperature. Celsius, this is Celsius and Fahrenheit, like you are seeing here. So now let us move. Do you know about the first thermometer? The first thermometer was invented by Galileo in 1593 AD. AD means Anno Domini. And this thermometer, air was used as a thermometric substance. So what do you mean by thermometric substance? It is a material used in the thermometer whose property varies with temperature. In order to assemble a thermometer, we use a substance that has some physical property which changes constantly as the temperature changes. Such substance is called a thermometric substance. Now, In this thermometer, air is used as a thermometric substance as air rapidly expands on heating and contracts and cooling. Further, the substance that is used in the thermometer has uniform expansion or contraction with the rise or fall in temperature. So, children, in our next session, we are going to do another activity and we are going to know about different thermometers like digital, clinical, and then Fahrenheit scale and thermometer. So, let us continue in our next session. Up to this, be happy and Allah Hafiz.